Hi folks. In this video we're going to look at how to sketch polynomials when they're not given in factored form and how to solve them if they're not given in factored form. So we've already established that factored form is great. It helps us find solutions and X-intercepts. So if you're not given something in factored form, you can probably answer this question right off the bat. What are you going to do? You're going to factor it. That will make it easier. So we've got this function over here. We've got to graph it. We've got to sketch it. We can actually make use of some of the nice features, very few of them, that we get from this expanded form. So from here, I can tell, since it's expanded, I just look at its highest power. Its degree is 3, or it's odd. Its positive, or its leading coefficient, rather, is negative. So its leading coefficient, negative. So its basic look is going to be from up to down, something like this. The other thing you can easily get from expanded form is the y-intercept. Because if I put in 0 for each of these x's, what am I going to be left with? Just that 6. Now, if you want to do it later, or if you want to show the subbing in 0, that's fine as well. But that gets us some of our stuff done. So we know the basic look. What we're missing, though, is the ability to find the x-intercepts. So let me erase all this stuff here, and I can see the function again. One thing that we mentioned earlier is that you want to factor out common factors and also negative leading coefficients. It just makes our life easier to factor something with a positive leading coefficient. So if I did that, I'd have negative bracket x cubed plus 2x squared minus 5x minus 6. This becomes our polynomial that we're going to try and factor. But we've still got the negative out front there. It's important. And to factor it, and this is from what we did right before the break, you have to look at the factors of 6. Those are the only possible candidates for integer x-intercepts. And we just plug them in. So let me put 1 into this whole thing. Now you might look at it and just see that 1 does not work immediately. So that's going to be 3 minus 5 minus 6. It's going to give us negative 8. Boo, we did not find a factor. That's okay, we'll just try the next one. P at negative 1. So again, I'm just using this polynomial and I'm plugging in the number negative 1. Negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6. I think it's a good idea to do these without your calculator. Keeps your mind sharp, and also it takes a long time to put them in the calculator. No, that's 7 minus 7. We just found ourselves a factor. And because it's this minus 1 that we subbed in, that means x plus 1 is a factor. Yay! Once we find that factor, we want to do our division. So again, we talked about this before the break. You can do it long division or synthetic. I think most people are going to choose synthetic. And I'm just using, again, this polynomial that's on the inside. So I have 1, 2, negative 5, and negative 6. I pull that 1 down, I multiply, and add them up. Multiply, add them up, multiply, that's a 6. Add them up, yay, I get a remainder of 0. So what we're doing, if you were to look at it in long division terms, is x cubed plus 2x squared minus 5x minus 6 divided by x plus 1. I guarantee you'll get the same result, though. You get x squared plus x minus 6. So what we learn from this is that f of x can be written like this. That negative is still there. Okay. It's got a factor of x plus 1. That we found, and then we divided and figured out leftovers was x squared plus 1x minus 6. That's what these numbers right here represent. And since we factored it a bit, we'll factor it some more. Negative x plus 1. Okay, how am I going to factor this? Adds to 1, multiplies to negative 6. Ooh, that's going to give us 3 and negative 2. And all that work lets us find the x-intercepts. Okay, there's an x-intercept at negative 1, because that's what would 0 at that bracket. At negative 3, that's what would 0 at this bracket. and a 2. That's what would zero out this last bracket. None of these have anything special. They don't have any multiplicity. They're not squared or cubed or raised to the power of 5. So they're just regular x-intercepts that the graph passes through. Let's sketch our graph with those properties. So I'm going to go back to blue here. Now I've got x-intercepts at -1, -3, and 2. Great. I know that it is odd with a negative leading coefficient, so it's going to go from up to down. And it's just going to go, see, it's going to go through at -3. Then it'll just go through at -1. And it will go through at 2. And the exact location of those maxes doesn't matter because we can't really figure them out with any accuracy yet. Okay. We're almost perfectly done with this. We just need to put in that the y-intercept was 6. And again, if you weren't sure about the y-intercept, you could just go and put in 0 here later on. -0 plus 1, 0 plus 3, 0 minus 2, and that would give you f at 0 is 6, which is the definition of a y-intercept, f at 0. If x is 0, you're on the y-axis. So there's our y-intercept. We found it earlier just by analyzing having this form, expanded form of the polynomial. The other thing that this question asks us to do is to solve the equation f of x equals 0. So maybe I'll take that down here. B, where is f of x equal to 0? Okay, so we could just put the original function. The f of x is negative x cubed minus 2x squared plus 5x plus 6. That was its original definition, equal to 0. That's going to be tough to solve like this. If we factor it, however, then we know that f of x is actually just that factorization. Negative x plus 1 bracket, and bracket x plus 3, and then another bracket for x minus 2. And when we write it in that factored form, well, the solutions are easy. They're whatever zeroes out each bracket. So that's going to be -1, -3. Try and write a legible 3 there. And +2. -3 and +2. The solutions to the function equals 0 are the same as the x-intercepts on the graph. Okay, that's their graphical meaning. To solve a higher order polynomial equation, you want to factor it, but you don't want to have to do it from scratch if you can avoid it. We already put in all the grunt work here to factor f of x, so let's just use the result by writing it in factored form and then easily seeing the answers. Let's do another one, this time a quartic. If you're feeling comfortable, pause and then just skip ahead and check your answer. Here we go. I've got no common factors. I've got plus or minus 1, plus or minus 2, or plus or minus 4 are the numbers that I could try. Of course, I'm going to try 1 first. And so that's going to be 1 to the 4. This is really annoying, writing these 1s out. Okay. When it's 1 that you're subbing in, you're just adding the coefficients. Okay, so it'll be 1 plus 4 plus 3 minus 4 minus 4. Oh my gosh, that's 0. We found a factor. X minus 1 is a factor. Yay! And so we'll go ahead and divide. I always write out that x minus 1 as a factor, though, to make sure that I write the right thing in the end. So 1's the number, and the coefficients. There are no missing powers of x, so we don't have to worry about, worry about placeholders. So now I just pull this 1 down. 1 times 1 is 1, and add them up. Multiply and add. Multiply and add. Multiply and add. What I've learned now is that this function can be written as x minus 1, which was the factor we found, by x cubed plus 5x squared plus 8x plus 4. Now, for the sake of completeness, I could try 1 again in this new polynomial that I'm going to care about. But I can see right away they're all positive. It's not going to work. Let's try negative 1. So that would give me negative 1 cubed plus 5 times negative 1 squared. Because I'm thinking about factors of 4 again. That final number has not changed. Plus 8 times negative 1 plus 4. Let's see, that would be negative 1 plus 5 minus 8 plus 4. Oh my gosh, there's 9 in the positive, 9 in the negative. We found another factor. And in this case, because we used minus 1, we found that x plus 1 is a factor. Yay! Okay, so we're just going to divide again. And I'm going to use the number negative 1 because we had that x plus 1 as a factor. And the coefficients come from this cubic over here. It's 1, 5, 8, and 4. And I should get a remainder of 0. If I don't, then I've goofed either the division or the number in the first place. Okay, negative 4. Oh, yes, remainder of 0. That's good. So here's what we know now. X minus 1 was a factor we found. X plus 1 is a factor that we found. And the leftovers are x squared plus 4x plus 4. Okay, now we're just going to factor again. So I'm wondering, what adds to 4 and multiplies to 4? The answer to that is 2 and 2. Okay. And now I've got it in factored form. I know my x-intercepts are 1, negative 1, and negative 2. And that negative 2 is squared, so it is a bounce. Now, I did this in a bit of a weird order. I probably should have started by figuring out the basic characteristics. This is a degree 4, okay, because its highest power is right there. You can also tell it by multiplying together the powers in the final form, or in the factored form. It's got a positive leading coefficient. And you can see right here that its y-intercept is negative 4, though you could also find that later on. So those are all the characteristics that we've got. Now we should be able to graph it. Intercepts at negative 2, negative 1, and 1. Okay. And it is degree 4 positive, so it has a basic look of kind of like this. So it goes from up to up. Let's see if I can do this. I'm going to come at this and bounce off of it, and then go right on through at negative 1, and then go right on through at positive 1. There we go. Now I just have to put that y-intercept of negative 4 in. Again, I don't know exactly where the turning points are, but that's a pretty good sketch. It's got the right axis intercept. It's got the right shape. We're good. You could check it on Desmos, and that's true for any of these graphing questions. One last one for us to take a look at, and maybe you want to pause and think about this one. This one's annoying because it does not have a constant term at the end, but that also means that it's factorable through just greatest common factor. So if there is a greatest common factor, you take it out. And you don't need any of the fancy stuff here. I can factor this as x plus 7, x minus 2. Okay. Now it's important to realize that that x out front really means a bracket of x minus 0. It also yields an x-intercept. It's kind of weird to see it as x minus 0, but that's what it means. So it's going to tell us our x-intercepts. Okay. X-intercept at 0 from this one, at negative 7 from this one, and at 2 from this one. None of them have any multiplicity. This is a degree 3, which is odd. It's got a positive leading coefficient, so its basic shape is going to be from down to up. And it's got the ghost of a 0 here. Its constant term really is 0, so its y-intercept is 0. But if you wanted to find it by, I don't know, by subbing in over here, you'd get y equals 0 times 0 plus 7 plus 0, or times 0 minus 2. I can't tell you the number of times I've seen students write that the answer to that is negative 14. Here you got 0. 0 times anything is 0. So the y-intercept's at 0. And it would be pretty hard to graph this thing if it were not the case, because you've got an x-intercept at 0. Okay, 1, 2, 3, 4, 5, 6, 7. There's an x-intercept. 1, 2. There's an x-intercept. And at 0, there's an x-intercept. That's also the y-intercept shown right here. Okay. And it goes from down to up. So we just, again, thread it through these x-intercepts. Something like that. Okay. So if you don't see a constant term, chances are you can use the greatest common factor, which is what we should be looking for in the first place anyways. In terms of practice, you can do page 147 to 149. Number 9, you could just do number 9. Or you could do number 9, then 7. Don't do every part of 7, just make the graph. If you're looking for a challenge, there are some for fun ones. And you can also do the Chapter 3 review, these particular questions. So there are a few that we've sort of taken out for this year. And please note that in questions 3 and 4, it tells you whether to use synthetic or long division. For this year, I do not care which one you use. You use whatever one is your favorite. So for number 3 or 4, just do your favorite type of division. I hope this has been helpful. Good luck with the material, folks, and take care.